So depending upon the AHG, the factors affecting the antiglobulin test, we were doing about the ratio of serum to cells and about the reaction medium. That is, if the reaction medium on what type of reagent is used to suspend the cells. That is whether it's albumin less or polyethylene, and that would in a way determine the incubation time also. So we have factors like these. Not in the ratio of serum to cells, but also the reaction medium. That is the reaction medium, what the reaction medium is, because that would in a way influence the incubation time. Then also the temperature of the reaction, which is ideally going to be 37 degrees centigrade. Then also about the saline that is used for washing, what the saline is, how many washings you need to give with the saline, and what is the ideal saline. That is, it should be fresh, it should be freshly prepared and not stored, because stored would have a decreased pH. And also the type of monoclonal agent that you use, if you use monoclonal AHG, even that would neutralize that would cause a decrease in pH. So all those factors that affect the pH would be there also. And also then we have the centrifugation speed. Then the reactions that factors that affect the centrifugation would affect the would be the speed at which the centrifugation is occurring, and also the. So now regarding the AHG, we also need to be conscious about what the AHG reagent is, or whether it's monoclonal or polyspecific, because a monoclonal would have a narrow pH range for optimum reactivity, whereas a polyspecific would of course have a polyspecific would be of course be capable of reacting with both the IgG and the complement components. And in a way, the polyspecific does not have any sort of interfering properties because of the left residual complement in the serum. It's only the free IgG which is left in the serum following inadequate saline washings that can neutralize the anti-IgG in the AHG mix. So the complement component is not neutralized by the anti-C3D or B in the AHG reagent because of residual serum. And then the centrifugation speed, we have gone through it, is ideally thousands RCF for 20 seconds. To increasing centrifugal force would cause false positive agglutination, and decreasing it too much beyond like below 500 RCF would cause the and false negative gluten. It would not cause the RBCs to become agglutinated. And also depending on how the button is suspended, for example, vigorous shaking would cause the negative result, and too inadequate resuspension would cause false positive results. Now, the sources of error are some of the most common causes of error are these which are listed below. That is, false positive results can occur if the improper specimen may cause in vitro complement attachment. So if it is a refrigerated or a clotted specimen, then there would be in vitro complement attachment, and over centrifugation and overreading would lead to false positive results. And the centrifugation after the incubation phase, when PEG or other positively charged polymers are used as an enhancement medium, would also cause false positive. So if we are able to go into the details of this antiglobulin testing chart. So we have things relating to not only the specimen and also the centrifugation, the centrifuge, the centrifugation speed, the time at which centrifugation is done, and then also the cells which are used for the serum which is used, or the saline which is used for washing, and then also even their properties of the cells. So the cells, even the RBC, the reagent cells which are used in the I8, even they, if they are polyagglutinated cells, then they may cause a positive reaction in the at the I8 stage. Then even the cells with a positive DAT. So if the cells in the edge, if the reagent cells are they should be O negative basically. So if they are like O positive, they have those, they will also give a positive DAT. So if there is some sort of some sort of problems with the cells. So in the if we go by the cells in the reagent cells, so cells with positive DAT will yield a positive IAT. Cells which are polyagglutinable will cause a positive AIG test, and then also cells with cells which are bacterially contaminated, then they, if they are used in the during the washing, they would also lead to false positive results. So these are three basically things that would that are sources of error with the cells that we use, the reagent RBCs that we use. Then there are other sources of error could be the centrifugation. Now the centrifugation, in the case of centrifugation, we have the centrifugation speed that would be, if it is over centrifugation, if we increase the speed too much beyond 1000 RCF for 20 seconds, then it may also cause the false positive agglutination. And also centrifugation, the time at which centrifugation is done, that is, if the centrifugation is done after the incubation phase when PEG has been added, because after PEG we do not need to centrifuge them further. PEG is a enhancement medium that causes aggregation of cells. So after addition of PEG, we do not need to do the centrifugation. So centrifugation after the incubation phase when PEG or other positively charged polymers are used as an enhancement medium can also give rise to false positive results. And then also the glassware that we are using, if there is dirty glassware, so if the reaction medium, not only the glassware would be important, that if it is dirty, then turbid, not only the glassware may cause turbidity, but also uh, the cells which are polyglutinable, and the bacterial contamination of cells may also cause turbidity. Turbidity may also be because of presence of fibrin in the test tube. This may also mimic agglutination. So and then also saline also may be contaminated, which may cause the turbidity. So the turbidity, the false positive results can be due to either the turbidity in the reaction mix, which can be due to bacterial contamination, or due to fibrin in the test tube, or due to contaminants like colloidal silica or heavy metals, others in the, which may be in the saline. Then there may be certain cells also which are polyagglutinable, or which are more which are DAT positive, and they are yielding a positive IAT. And also then using the and also in the patients, so not only problems with the cells and the reaction media, but also with the centrifuge, and then also problems in the serum sample, that is the patient serum sample which is used. If we use a serum sample for a DAT, which is the one which is collected in EDTA, or in this from a blood bag, that is the CPD or ACD anticoagulated bag, if the serum sample is collected from here also, so this may also lead to false positive results due to inappropriate complement activation. So samples collected in gel separated tubes, and also in gel separated tubes, they may have unauthentic complement attachment. So even this EDTA may also cause unauthentic complement activation, and even the gel separated tubes may also cause unauthentic complement attachment. And then the complement attachment may also occur when specimens are collected from infusion IV lines following the dextrose solutions. So preservatives dependent antibody directed against so there may be also antibodies which are preservative dependent, which are there against the reagent. So when the reagent is added, EIG reagent, if it's a polyspecific reagent, they usually have preservatives for extending the half-life of the reagent. So those reagents may also decrease the pH, or they may affect the pH of the mixture, and then lead to preservatives may also cause antibodies to be formed against the preservatives, which may cause false positive reactions. That is, the patient, the antibodies may not be coming from the sera, but they may be coming from and they may not be coming from the sera, and they may not be directed against the RBCs, but they are actually directed against the reagents. These antibodies are directed against reagents. So in a way, we have 12 to 13 like causes for these false positive AIG, and those can be further divided into causes that are due to the patient sample, that is the patient's serum sample which is used, either if it is improperly collected. So regarding the specimen of the patient, if it is collected in if it is collected from an IV line, so if it is collected from an IV line, from an IV dextrose line, then also that would lead to complement activation. Then if it is collected in a gel separator tube, so even that would be cause unauthentic sample activation. And also if it is collected in an EDTA tube, or an ACD or ACPD sample is taken, then even that would cause inappropriate complement activation. And also if it is refrigerated or if it is clotted. So even if the sample is clotted, if you have a clotted sample or a refrigerated sample, or it is stored for too long, even that may lead to false positive results. So there are problems with the specimen. These are problems that we are dealing with the specimen. Then there could be these are like 4 problems that we have regarding the specimen that we have of the patient, which is basically the serum of this patient. Then when the when the I8 is being AG is being used in the I8, then we have the RBC suspension. Now the RBC suspension, there can be problems in the RBC suspension. The RBC may contain cells that are polyagglutinable, so there could be like polyagglutinable cells. Then we have cells that can be but that may show bacterial contamination. So the reagent even may have bacterial contamination of the cells. And then there could be some cells that will show up that are the reagent cells may be positive or maybe O positive, so they will give a positive DAT. If they are D, if if the D antigen is positive, so they may with the or cells with a positive DAT, they may also give a positive IAT. So we have like 3 problems with the cells that are used in the sample mix. And then we can have problems. So we have problems with the sera, we can have problems with the cell, then we can even have problems with the AHG reagent that is used. If the AHG reagent is if the AHG reagent is if the agent reagent contains certain preservatives, if it has certain preservatives, and the antibody will not be directed against the RBCs, it may be directed against the preservatives. And if also the so I think regarding the AG reagent, we may go along with if we may, it may depend upon whether it's a polyclonal or monoclone specific also. So that would also depend. That would also affect the pH. So poly or monospecific AG would also uh, uh, affect the positivity of the AG results. So the reaction basically, if we are going by the reaction, so in this reaction which was occurring, there could be problems we have seen can occur both with the reagent red cells, and then both with the serum, and then also with the AIG reagent. So there can be problems with the reagent red cells, that is, they can be bacterially contaminated, they can be polyglutinable, they can be DAT positive, and there can be patients problems in the sera, also analytical problems in the sera, that is how it is collected from, if it's collected from IV lines, if it is collected in EDTA tubes, and if it is collected in if the serum is in its if there are any gel tubes that are used for collection, if it is collected in gel tubes, then also if it is there is some in sort of in contamination in the sera from bacterial contamination also, and all that can cause problems. And also if it is stored for too long, that is if it is stored or refrigerated and then used in the mixture, even that can cause problems. Then there can be problems with the AHG reagent. That the AHG reagent that we are using, it may be it may be poly or monospecific. That would also affect the false positivity of the reaction. Then also if it is if the AIG reagent is contains certain preservatives against which the antibodies may be directed. Then of course there are the non-specific false positive results that may be due to the glassware that we are using. The glassware may be dirty, the glasses may be contaminated with fibrin from previous tests if they're not properly washed. And then also, of course, not to miss is the centrifugation. So we can have problems with the 3 components of the reaction mix. Then we can have problems with the with the with the with the with the instruments that we are using. There can be problems with the glassware, there can be problems with the centrifuge, as if you're over centrifuging it, even when that can lead to false positive results. And also then with the agglutinating reagents that we're using. So, for example, if you're using PEG as with, and we're centrifuging after the incubation with PEG, that may also lead to false positive results. Then even fibrin also may be contaminant, like the same as with dirty glassware. You can have even fibrin in the test tube, may make positive reactions. So this in a way sort of sums up the false positive reactions that we can see with AG reagents. Then coming to the false negative results, of course, they will be like the opposites of what we have seen so far. So A false negative would starting from, if we start from the cells that we are using, so the reagent cells. So if you do not improperly wash the cells after, as with saline, or if there is a failure to wash three times, 3 times is like a must minimum. And you can even increase that beyond 3 times even, it can be added. Then contamination of the AIG by extraneous proteins, for example, glove or wrong dropper. If wrong droppers are used, there can be contamination of the AIG. This can be the same as a dirty glassware, or fibrin. Like if you're using a pipette that was used to sample serum and then use it again for sampling AIG, you may pick up some fibrin also. Then false negative results can result because of cells, even that the cell to serum ratio is not ideal. The cell suspension is either too weak or too heavy. That is, it should ideally be basically a 3 to 5% suspension. So if it is more than 5%, if it is too heavy or it is too weak, then even that ratio would be disturbed. So the cell to serum ratio is important, and the cells, either if they are um, uh, too weak or too, if they are too if their cell to serum ratio is either, cell suspension is either too weak or too heavy, that would affect the reaction also. And then also, if the cells are so we are dealt must with the cells, that is the serum to cell ratio, and then the washing of the cells. This is what is important regarding the cells. Now then, regarding the sera that we are using, now there are a lot of false negative results can occur, not because of the serum to cell ratio also, and also because the fact that the serum may be there may be residual serum left after the washing, which can and so serum may be left even after the washing. Then there may be high concentration of paraproteins in the serum also. If they may lead to false negative results with the AHG, because they may coat the RBCs. So false negative results can occur due to paraproteins in the high amount of paraproteins in the test tubes. So here we need to wash the cells very vigorously, because so as to remove the paraproteins also. And the serum then also needs to, if there's high concentration of IgG in the serum, then that would also lead to false negative results. Now, because that the antibodies in the sera would then not be able to bind with RBCs because of heavy immunoglobulin contamination. So hypergammaglobulinemia. Then other early, then there could also be problems due to the serum being excessive heating or repeated freeze thawing of the test serum. So if the serum has also been obtained, has also been collected and then frozen, and then it is thawed and then used in the HT mix, even that would affect it. And then also the serum which can become non-reactive because of deterioration of the complement. So this is again the time, if the way in which the sera is collected from the patient. If the serum is collected and then thawed and frozen and used, yeah, then it could lead to a negative AIG. That would also weaken basically the complement it could cause deterioration of the complement, and also the immunoglobulins may be destroyed also because of this repeated excessive thawing and heating. And also, if the time is too much between the test and between the drawing of the sample and the testing, the sera may even show deterioration of the complement dependent antibodies. So so the way you handle this sera would actually also affect it, because as we said, that if you take it from IV lines, and if you add it in gel tubes, and if you add it to ETDA tubes, so that will cause an unauthentic complement activation. And there could be other ways in which the complement may deteriorate, so that the complement to the complement specific antibodies may not be detected, because the complement has deteriorated in the serum because of too late a testing being performed into, and the repeated frozen, freezing and thawing of it. And heavy amount of paraproteins in the serum may also lead to deterioration of the serum sample. And then we had gone into the facts about the cells also, that the cell suspension either may be too weak or too heavy, or the ratio may not be ideal, and the cells may be improperly washed, so that they still have some bound plasma proteins also. So, and then also, then regarding the RBCs, and they may be then regarding the AIG reagent, the contamination of the AIG reagent may be because of proteins that have been that may come because of the AIG reagent being left open for too long, or out of refrigerator for too long, and with the wrong droppers being used. during testing and not switching, not using fresh droppers each time. And then also the timing of the testing is also that that first of all the when the serum is drawn, it should be immediately in a way tested for with AHG, otherwise the duration of the complement can occur. And also if there is interruption in testing, there can be a dissociation of bound IgG from the from the RBCs. This is particularly if after the washing and the centrifugation, if you do not add the AIG uh, uh, um, quickly after that, at that point, the bound IgG may elute from the RBCs. So there could be early dissociation of bound IgG from RBCs due to improper testing, temperature even. So testing time also, it is important, and the temperature is also important for the IgG, for the immunoglobulins to remain bound to the IgG. For the AIG to detect it, and also if the AIG is contaminated also by extraneous protein, this may lead to false negative results. Then there could be AG reagents which are non-reactive because of deterioration or neutralization, that is improper reagent storage. And then AG reagent or testinum, if it is not added, of course, if you just miss out adding any of the reagent mixture, that may also give rise to a negative test. And this is like some of the one most common cause, I think, of this false negative reagents, because once you have too many test tubes in hand, and you have to add the sera and the enhancement media and the reagent red cells and the AG reagent to all of them, sometimes you may miss out some reagent in the mix, test tube mix. Then also rare antibodies are present that are only detectable with polyspecific AG. So the AG may also give a negative test if the rare antibodies are present which are detectable only with polyspecific AG, and when the complement is active complement is ready. So there may be certain antibodies that have some specificity for certain AG reagents to detect them. Then the low pH of the cell line and inadequate incubation times in the I8 and poor reading techniques are cause general false negative results can be obtained because of this. So if we have like the false, if you have like poor reading techniques and inadequate incubation conditions in the I8, and so starting with first the spinning, the centrifugation, and if you fail to suspend it, and also if you, there is uh, there's problems in the RBC reagent, in the RBC reagent cells, and then problems in the serum, and then problems with the AG reagent. And then we went to do all into, when all of this has been added and they are centrifuged, there could be problems in the centrifuge, and there could be problems in the reading technique, and also in the incubation of this serum and cells. So there could be problems at all stages, in the RBCs, in the sera, and the incubation time. Then when the AG is added, then the AG may be contaminated with the extraneous proteins, or it may be sort of a whether it's polyspecific, monospecific, that will determine certain rare antibodies that may be present in the sera against that may be detected by specific types of AIG reagents. Then also the reading techniques that are used. That is, if you do not take the if you do not read it microscopically, or if you do not view it under an agglutination mirror, you may some sort of miss certain agglutinations, and they may be cause of false negative results. So this in a way mm, summarizes all that we have done about the antiglobulin test. So we've gone into much of the about the sources of error. Now, just the last bit that we'll be doing is about the solid, the gel phase, and these modern uh, techniques that we are using, and that would in a way wrap up our chapter. So regarding these modern techniques that are in place now, we have even AIG not and alone in test tubes. We can do it in solid phase technology with gel tubes. So the solid phase may be used for performing antiglobulin tests, and several different techniques have been reported using either test tubes or microplates. So a solid phase can be done either in test tubes or in microplates. Mostly it's done in microplates with the availability of microplate readers. This has become fully automated. Now, direct or indirect tests can be performed using solid phase methodology. And in the, so both the direct antiglobulin and the indirect can be performed. And in the former, that is in the direct phase, the antibody is attached to a microplate well, and the RBCs are then added. So in this case, we have the sensitized RBCs of the patient, which are added to the microplate well, which is coated with the antibody. This is for the DAT testing. Then, so if the antibody is specific for antigen on the RBC, the bottom of the well will be covered with suspension. So then we will have agglutination at the bottom of the well. And if no such specificity occurs, RBC will. So if we have if the antibody is specific for antigen, the bottom of the well will be covered with the suspension. And if no such specificity occurs, the RBC will settle to the bottom of. So if they settle to the bottom of the well, then they will. Then this is not a reaction. If they coat this sort of well, then this means that the antibodies have reacted with the RBC antigens. In the latter, known RBCs are bound to a well that has been treated with the glutaraldehyde or poly-L-lysine. So, test serum is added to the RBC coated wells. So once so we have first of all the wells which are coated with the antibody, and then when the RBCs are added, they will sort of line uh, these wells if they are specific for the antibody antigen on the RBCs. So then they will become lined with the RBCs, and otherwise the RBCs will settle to the bottom of the well. And in other case, they will line the RBCs, and then when the AHG reagent is added, this if the AHG reagent is added, then if the antibody in serum is specific for antigens, a positive reaction occurs as previously. So the test serum is added to RBC coated wells, and if antibody in serum is specific for antigen on fixed cells, a positive reaction occurs as previously described. So for a detailed description, of course, we will have to go to this chapter number 12, which is for blood banking testing technologies. So in this case, the we have the direct antiglobulin, which will test the antibodies attached to the microplate valve, and then the RBCs are added on the patient RBCs are added on top. And if no such specificity occurs, RBC will settle to the bottom of the well. In the latter, even the RBC settle to the bottom, the RBCs are bound to a well that has been treated with polyglutaraldehyde or poly-L-lysine. Now, test serum is added to the RBC coated wells. Now, if now this in the case of that we have antibody coated wells. So, in the case of I8 we have these RBC coated wells. So this was in the data in the direct antiglobulin testing. In the indirect antiglobulin testing, we have IRBC coated wells, which to which if we add the patient sera, then they will cause they will cause this positive reaction, which is the same as the one over here, where there will be coating of the well. So this is the difference in the wells for the DAT testing and the in direct antiglobulin testing. Then for the gel tube test, it is a process that detects RBC antigen antibody reaction by means of a chamber filled with, so here we had the wells which were coated. Now here we have chambers. Basically, there are sort of cuvettes which are in which the reaction takes place. There's a chamber filled with polyacrylamide gel. So we have polyacrylamide gel in the chambers, and the gel acts as a trap. So basically, this is a trap mixture. Here, the free unagglutinated RBCs forms buttons in the bottom of the. So if they are able to pass through this, they will form buttons in the body. They have not reacted with any of the constituents of the gel. So whereas agglutinated RBCs are trapped in the tube for hours. And therefore, the negative reaction appears as a button at the bottom of the microtube, and the positive reactions are fixed in the gel. So the positive reaction would then be also the coating. So then this would also, there would be like, if the tube is, if the button is at the bottom, it's a negative tube. If it is 1/3, this would like show the severity of the reaction, whether it's 1/3 agglutination, or if it is the 2/3 agglutination, there will be 2+ reaction, then 3+ for if it is coating the 3/4 of the tube, and then if it is coating the whole of the tube, it will be 4+ reaction. So the reaction strength can also be determined, and then this button would also remain there trapped in it for hours, so that can be reproducible, and this can be even like, you can save this reaction for quite some time, even to show if this was done somewhere at night, they may be able to keep this as a record even. So comparison of AHT methodologies is done here. We have the saline tube testing, and we have the saline tube testing, the LIS and the PEG tube testing, then we have the gel in the solid phase. So the saline tube testing is because there will be no additives attached. Of course, there will be reduced cost, and this avoids reactivity with the auto antibodies, and we are able to assess the multiple phases of the reactivity. But the disadvantage is that too long an incubation would require 60 to 120 minutes, perhaps even, and it is not specific and requires highly trained staff and a lot of procedural steps in between. Because we know that with gel in place, we just have to add either the patient RBCs or the patient serum, and just the antibodies are already coated with the wells are already coated with the reagent cells or the serum antibodies. So, but with the saline and tube testing, of course, we need, and with all of these SLIS and peg-based tube testing, there are many procedural steps, and there will be highly trained staff for all of them, and it requires although the long incubation is for serum, and for these, of course, a little incubation time is there for 30 minutes for this, and we have we have like 10 to 15 minutes for both of them. So the incubation time would of course be decreased in both of them, but the procedural steps are too many, and too highly trained staff is needed, and you cannot make it automated, and sometimes then the reactions would also not be very useful. So fewer method dependent antibodies are detected. But so the method dependent antibodies are not detected in this. And then the advantage is that, of course, we would be the advantage of listen tube testing is that this avoids reactivity with auto antibodies, because we'll be using the patient's serum and the RBCs as separate reagents, and it will be increased antibody uptake. In most common tube test method is the LIS one, and you can able to assess the multiple phases of the activity. So the phases of the activity, because we go through different phases, like immediate spin, the incubation period, then the addition. So we can find out at which stage the antibody is reacting, and this will also specify the specificity of the antibody would also then be documented. So basically, the disadvantage would be that it requires too many steps, too many staff, and less sensitivity. But the advantage would be, of course, that we are able to look at all the phases of the reaction, and also the it is like reduced cost, and then you can find out um, if you're able to pick up most antibodies, and this is particularly true with PEG, because you will not be mixing out any clinically significant antibody, and this enhances most antibodies, so this will be increased antibody uptake with this. But the gel in the solid phase, what they advantage they have, that they are more sensitive than the DAT. But and with gel, no washing step is there, no check cells are needed, and they're stable endpoints. That is whether how much the gel is agglutinated, which shows stable endpoints, and a small volume is needed for the test, and there can be enhanced anti-D detection with the ability to be automated. And then the solid phase also, it's a stable endpoints and small volume testing and enhanced anti-D detection and increased sensitivity for all antibodies. And but the disadvantage of these would be that, of course, the cost is increased in this, and warm autoantibodies are enhanced with the solid phase. So the IgG type would be enhanced, and this detects unwanted antibodies also. But the solid phase would be detecting, just like in the tube test testing, we had PEG, which was detecting increased antibodies uptake and enhanced, and most antibodies were being detected. And in fact, not it did not miss any clinically significant antibody, but it could pick up some clinically insignificant antibodies. So with PEG, although you had the advantage of being very specific, but it could be that it was detecting too many, detects more unwanted antibodies. So this is the same in the gel and the solid phase also. We have the solid phase, which is detecting many unwanted antibodies. And the warm antibodies, they are usually enhanced with both the gel and the solid phase. So then there is increased need for additional instruments needed, and increased chances of detecting unwanted antibodies um, with both the gel and the solid phase. So these can detect unwanted antibodies, and the solid phase has more sensitivity for all antibodies, so it can detect all of them. Although the warm antibodies are enhanced with both the solid and the gel phase. So with this, we have some sort of summarize this chapter. And the antiglobulin test, we know, is used to detect the RBCs coating. The RBC is sensitized by the IgG antibodies or auto antibodies in the complement components, and the AIG reagent containing anti-IgG are needed for the detection of IgG antibodies. because the IgG monomeric structure is too small to directly agglutinate the sensitized RBCs. Then the polyspecific AIG serum contains antibodies to human IgG, and so the polyspecific has in a way antibodies to both the IgG and the C3d, whereas the monospecific has only antibodies against the C3d or the IgG. So they will be like or. And then the classic AIGs are usually polyclonal, and they are made by injecting human immunoglobulins into rabbits, and then using a clone from a mixture of these antibodies, whereas the hybridoma technique is used to produce monoclonal antiglobulin serum. Then the DAT detects in vitro sensitization of RBCs with IgG or complements, and this would detect the HDFN, HDR, and autoimmune hemolytic anemia, and the I8 would detect in vitro sensitization of cells, and this is used for the compatibility testing, antibody screening, identification of our antibodies, and RBC phenotyping and titration studies. Now, the positive DAT is followed by a DAT panel. We have a DAT panel that would just check the specificity for whether it's for IgG or C3d, and then whether it's warm or cold autoimmune hemolytic anemia, or for um, whether it's cold, and whether it could be polyspecific, or whether it could be paroxysmal cold hemoglobin urea or CAS. Then the EDTA should be used to collect the blood samples for the DAT, to avoid in vitro complement attachment associated with refrigerated and clotted samples. So for DAT testing, we can use EDTA, and there are and in this case but for indirect testing, the EDTA is in a way avoided, because then there may be unnecessary complement activation following this. But there are multiple sources of error that can be introduced into the AG procedure. They can be due to the enhancement medium also. Each has its own advantages and disadvantages, and the conventional tube testing and gel technologies and the enzyme linked and solid phase are also available, and method dependent antibodies do exist. So this is something important, that method dependent antibodies do exist and should be evaluated by a case to case basis. So this is important specifically when results between labs or after some time are becoming different from what they usually were. So there could be method dependent antibodies as well. So I think we'll take a short break here, and then we will continue with some certain cases, probably, or the review questions. We can go through that so that we have, in a way, completed the chapter altogether. If there are any questions that you have, you can also raise that in the question week. So we'll just take a short break, and then you can rejoin again using the same link that was given in the WhatsApp group, and resume after 5 minutes.